So we're going to continue our conversation here as we are building up some basic skills so that we can understand the issues surrounding energy, energy efficiency, and energy conservation in the context of modern society. Okay, so first of all, I want to review for a second how we quantify the amount of heat that is released. In these combustion reactions, one of the products of a combustion reaction is energy in the form of heat. Heat is given off. You know that you burn wood in a campfire so that you can warm yourself up or cook your food when you're camping. So heat is one of the products, considered products of a combustion reaction. So we can actually quantify how much heat is given off when you react a certain amount of matter, because the amount of energy given off is directly proportional to the amount of matter that you are combusting. So for example, if you assume that 48 kilojoules of heat are released when 1 gram of octane combusts, you can calculate how much heat is released when 1 gallon of octane combusts. Okay, so the information that we know about octane is that it gives off energy. 48 kilojoules of heat energy is released when 1 gram of octane combusts. All right, that's a known quantity about octane. So then you can calculate how much heat would be released if you were to go ahead and burn 1 gallon of octane. So in this case, what's given is a certain amount, 1 gallon of octane, and what's wanted is how much heat energy is given off. Okay, how much energy is given off. In this case, it's in the form of heat. And the conversion path is going to be from a volume, gallon of octane, to energy in units of kilojoules. And so we know what's given is the amount of heat given off for 1 gram. So it's also given that 48 kilojoules of heat energy is released for every 1 gram of octane that is burned. So we know if we can figure out the mass, we ought to be able to figure out the kilojoules. So we need to convert from gallons to a metric volume unit to grams to kilojoules. Okay, and so the gallon to milliliter unit conversion, that's going to be what we looked up the last time we did this kind of conversion, and that was that there are 3,785 milliliters in a gallon, and then to get from milliliters to grams, you can use your density of octane, which was given in a previous example, 0.692 grams per milliliter. And then to get from grams to kilojoules, we have this conversion factor right here that we can use. So why don't you go ahead and turn off the tape real quick and see if you can come up with the answer to this problem.